All right, we're now on the assignment for section 4.3. This is about inscribed triangles inside circles or circles inside triangles or such. And it's not as hard as it might look when you see this diagram and such. It might be a little bit intimidating, but it's really not difficult as you go through, just as long as you know what you're doing. So we'll go through each example and hopefully help. I might make some mistakes. If I do, just send me a correction or, just fix it yourself, whatever you want to do. But here we go. If the measure of an arc, now, definition of an arc is just like this one, arc SR. So the arc is considered the circle around, that touches here. So that's an arc. So if the measure of that arc is 117 degrees, you want to calculate what this angle is here. Okay, so as you know, on a circle, an entire circle is 360 degrees. So when it says a measure of an arc, it's just a measure of a section. From here to here, this is 117 degrees of the total 360. So if we said, what's the measure of the circle, it would be 360 degrees. But if it's just the measure of an arc, it's just a section from the points that it gave you. So from S to R, it's 117 degrees. Now, the formula that you use if you have a triangle that connects with that arc like that is that the arc is double the angle. So you take this 117 degrees and you divide it by 2 to get this angle right here. Okay, and you can see, if you're looking at it, you can see that this is bigger than this would be. If you have a center of a triangle and you connect it all, that angle right here would be 117 degrees. So if it connects to the other side of the triangle, then it's half whatever this is. So you take 117 and divide it by 2, and you get 58.5. Okay, so if you have the measure of the arc, and the lines go to the other side of the circle, then it would be half the measure of the arc. I repeat this sometimes, just hopefully that it makes a little bit more sense. Okay, for this one, measure of RST. So RST right here is 40. So this angle right here on the triangle is 40 degrees. We want to find the measure of arc, RT. So it's 40 degrees. It has to connect like a cone. It looks like an ice cream cone, a snow cone, whatever you're saying, it has to be a cone. So if this is 40, then the arc is double it. So the arc then would be 80 because this small portion down here, the point of the cone, is half the measure of the arc. So it's half the measure of it. You take this and double it to get here. Okay, because the arc will be bigger than the point of the cone. Okay, next problem. If the measure of arc, SR, so we go SR is 106, and it labeled it there for us. It wants to calculate what STR is. Again, this is that cone that we were talking about. So if the arc's 106, this would be smaller. So you divide, the point of the cone is always smaller. So you divide it by 2. 106 divided by 2 is equal to 53. There's the answer right there. Okay, if you have this problem like a SRT, let's see, measure of SRT right here is 52 inside there. Find the measure of arc ST. It wants the measure going from S to T. Remember, the point of the cone is smaller than the arc, so we would double it, 52 times 2 to get there. So 104 is the measure of that arc. Now, these are ACT type questions. I mean, you might see one of these on your test as far as arcs, and This is a common question where it might give you the arc and you need to know this angle, or it will give you the angle and you need to know the arc. I've seen those before. Okay, question 5. In circle T, is it possible to determine that where are we at? ZTW, the ZTW right here, is a right angle? Now look at it and you can see, as far as looks go, I mean, it is not possible, I would say, false, because it doesn't give us any angles. If it gave us some other angles, we could say if that was a right angle or not, but it does not have to be. All we know is that these two together have to add up to be 180 because it's a straight line. But we're not given this information of what these other angles are. And so it does not necessarily have to be a right angle. And most often it isn't. So that would be false for that problem. Okay. If we're given LKJ right here, LKJ, and it tells us that that's 50, we want to find what LKJ is. Sorry. The question is, we're given that this angle is here, and it wants to know what LKJ is. Well, that is the definition of it. This angle or this arc is the same as the center angle that touches the center part. Okay? It's half if it went from there to there. This angle would be half of theta. But the whole problem that it's asking us is what is this angle that touches the center point? Well, by definition, then this is theta. That's the symbol for theta, but all it means is like an X, or they just call that for an angle. So LJK must also be 50. Because that's the definition of what this is from the center out is that angle. Okay, next problem. Find the measure of the arc TSR, so it wants to know the measure of the arc, so it says it right there, if this angle right here, theta, is 48. Okay, so remember the point of the cone is smaller, it's tinier, you see this tiny, so if it's smaller I have to double it. So you take 48 and you double it and you get 96. So the arc itself would be 96. Okay, so find the measure of LIK. So you have the LIK if theta here is 68. So if you have the theta here, now it doesn't, do you see how it kind of curves, like it doesn't go straight, around it or whatever the center, it goes through the center here. It's still considered a cone because it touches this and this point. So if LK or this theta is 68 degrees, then this angle here, which it's asking for, is half of this still. So you just take 68 and divide by 2 to get that. So even if it goes kind of off to the edge and it's not completely symmetrical like we've seen in those others, the rule still holds because the top of the cone and the top of the cone, these lines touch the edges of that arc. So it doesn't matter if it's clear here, then this angle would still be 34. If it connects over here, let me use a different color so you could see maybe better. If those were straight lines, this angle here is still 34. It doesn't matter where that touches on the outside of the circle, that angle will always be 34 if it comes from this point and this point, and this angle right here was 68. So hopefully that makes sense. And not so much, there's a lot of scribbles there, but sorry. Okay. Measure of LIK if this angle here is 50. So this is the same kind of thing. If this is 50, the center point, then you take it, still touches L and K, continues over here, it's half it. This angle would be half of this, which is 25. Okay, number 10. Oops, I went too far, so I can't read it. All right, here we go. Find the measure of the arc if this theta right here is 33. So if this angle here is 33, I want the measure of the arc. Whoa, I looked at that wrong. So make sure you look what it said. It said TQR. And TQR, you start at the end and it comes around like this. So it's the opposite, it's all the other. When I first looked at it, I thought it was asking for this. And instead it was asking for this other part, that maroon part. So first, figure this. So this, if the tip of this is 33, then the tip is the smallest. So you double that to get 66 out here. Okay, so if this is 66, what is this? Well, the whole circle is 360. So you take 360 and you subtract the portion that you want to take out. You take the whole and subtract the part out of it, and it will get this bigger length there. So 360 subtract 66 is equal to 294. And so that's what would be here. This whole arc from TQR is 294. So you find out this section and subtract it from the whole. Okay. Find the measure of IK if, so it wants the arc IK, if theta right here is 69. Okay. So IK is this other section. Now, we just need to look at this. From here to here is 69. I want to know what IK is. Now, when you look at that, there's a diameter that goes through here. And half of a circle, if the whole circle is 360, half of the circle is 180 degrees. Or you could say it's on a straight line. And so half the circle is on that straight line. And so it's 180. I put percent there, but that's supposed to be degrees. Anyway, sorry about that. I wonder if I can, there we go. That's easier. So it's 180 degrees. So what you do is you take the whole, I just want IK, and this is 69. So I take the whole half of the circle, which is 180. I subtract 69 from that to get this portion right here. So 180 minus 69 is equal to 111. So this IK, the arc IK, is 111. 12. Measure of L, the angle, let's see, it says LJK. So LJK. It wants to know what this angle is if theta right here is 61. And it would be 61 because that is the definition of theta, is where it goes into that center right here. But the angle LJK is equal to whatever this arc is or whatever. So 61 degrees. Okay, find measure of TSR. So this is an angle. They want this angle. If theta over here is 35. Okay, so here's a definition of a quadrilateral. Whenever you have a quadrilateral, you see how this is one side, two side, three side, four side. That is a quadrilateral. Quad is 4. So if you have a quadrilateral that is inscribed, and inscribed means inside and touching the edges of the circle. So if it's touching the edges of the circle, always, 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 the angles opposite of each other are supplementary. Okay, they have to add up to be 180 degrees. So angle TSR, this one right here, has to be the total 180 because these have to add up to be 180. So I take 180 and I subtract 35 from that, and that gives me TSR, which is 145. So the opposite angles must add up to be 180 in an inscribed quadrilateral in a circle. Okay, 14. So it looks like this is similar. The measure of arc, no, it's not. Measure of arc TQR. So it wants to know what TQR, this whole arc here, if this angle here is 40. Okay, so the total is 360. If this small part's 40, then from just here to here has to be double that, which is 80. Okay, so then you take the total 360s and subtract this portion in order to get this portion here. 360 subtract 80 is equal to 280. So that's how you solve for this arc. I mean, the big arc. So we solved for the small arc first because we had this information, subtracted it from the whole to get it. Okay, last question on this particular assignment. Find the measure of arc TSR. So we want to know what TSR is this time if theta is 32. So this is easier. I don't have to subtract it. I just take the small part and double it, making it 64 degrees to get TSR. So that's all the problems on this. If you do have any questions, please reach out to me. I'll meet with any of you one-on-one now. I can have you come in and help you through this if you need, but please reach out if you have any questions. Hopefully that helps.